A very good afternoon to all our matrics out there, all the parents, teachers who might have joined. What a wonderful opportunity to welcome you to the Maths Hour. If you are wondering what this is all about, the OldMutual Foundation launched the 21 Acts of Goodness to enable the matric class of 2020 by providing some extra support and encouragement to all our matriculants. I would say much needed support and encouragement in this year of the pandemic. When Macmillan heard about it, we literally grabbed the opportunity to support the class of 2020. Today is your day. Apart from being very hot outside, we are going to address a very hot mathematics topics because we want to show all the matrics attending this math revision session that with the very important final exams around the corner, Macmillan have your backs. All the 21 Acts of Goodness partners are there to support you as well as your teachers and parents. Now, matriculants, if you are struggling to apply your knowledge in maths, don't fear. You are definitely at the right place this afternoon. Welcome to the session, and we all know that you can do very well in maths this exam. Now, to get you connected, I want to just share with you, we would love your interaction with us. And on the control panel, it will appear on the right side of your screen. You are able with that little wheel, we call it, that waffle on the right-hand side where the arrow points at, you are able to download all the material that are going to be discussed this afternoon. So please don't miss out on that opportunity. And please also test your audio. That can be adjusted so that you make sure you are connected and you can hear well. This is so important because we want you to interact with us. There's a control panel. It looks like a little speech bubble that indicates a chat box option. Now that's where you can post an answer, where you can put a question, where you can make a comment, anything that you would like to tell us. If you're having a problem with your connectivity or something you want to know, please make use of the chat box, type your message. Now, I want to say welcome to Sehu Matlala. Sehu, you know, when I told him that yesterday was just brilliant, I'm not a mathematician. I enjoyed every minute of the workshop. His 23 years of teaching, lecturing, and facilitation experience, including project management, actually is the reason why he's on here today. He speaks from, I could hear the love for mathematics. And for those of you who are going to study next year, University of Johannesburg, Sehu is currently a mathematics lecturer and a PhD student. He's also part of the Macmillan Teacher Campus family because he was a project manager with us. And you know what? I would love to hand over to you, Sehu. Take your learners, your matriculants, your teachers, everybody on board and share your passion and your love for mathematics. Thank you so much for having us this afternoon and enjoy this session with everybody. Thank you, Sehu. Over to you.
Thank you, Martha. Good afternoon, learners. Good afternoon, everyone. My name is Sehu, as Martha has indicated. Today, we're going to continue with trigonometry. This is part 2 of trigonometry. So yesterday, we discussed the part 1, and today we continue with part 2 of trigonometry. And in today's lesson in particular, we will look at compound angles as well as the double angles. Please feel free to participate in this lesson, ask questions and comment where possible. You are free to ask questions at any moment. Okay, but before we deal with the compound angles, there are tools that you need to know that are relating to compound angles. These are basic formulas that you need to know. Okay, the first compound angle that you need to know. Remember, the compound angles are angles that deal with double angles, like the one that I've presented here. You see that I've got the cos of alpha minus beta. Cos of alpha minus beta. So these, some of the students will say cos alpha minus cos beta. Remember, it's not like that. The cos of alpha minus beta, you cannot say cos alpha, you cannot say cos times alpha, cos times beta. But the cos of alpha minus beta is the same as cos alpha cos beta plus sine alpha sine beta. And this you need to remember from the heart, that the cos of alpha minus beta will always be cos alpha cos beta plus sine alpha sine beta. And then how do you remember this? You'll notice that if it's a minus here, say for example in this case, you have got a minus here, you see that is the cos of alpha minus b. Look in the middle of the two terms, then it changes to a plus sign. So just remember that if it's a cos, you see that it's alpha minus beta. So the minus, because it's minus, then here it becomes a plus. And remember also to remember this. Remember, you must have clues of remembering these formulas. Say, for example, again, you can also see that it's cos and it's also cos. And on the other side is sine and it's also sine. Even though these formulas are provided in the formula sheet, you as a student also, you need to know them. You need to identify them very well. So that will be our first compound angle formula that you need to know. All right. Okay, let's proceed to the next compound formula. So I'm just going to erase all these drawings that I made here. Okay, the next one is that one. I think students, most of you are familiar with these formulas. Yeah, I see Joy here has asked the question. Hi, sir, I joined yesterday's session. Is it possible if yesterday's notes can be available? Okay, Joy, I think someone has responded to you now, so you'll be able to get notes after you have provided your email. Thank you so much, Joy. All right, okay, the second compound angle formula that you need to know. Remember the first one was cos with a minus. So the second one is now the cos, but we are using which sign now? We are using a plus sign. We are now using a plus sign. It's no longer a minus sign, but it is still a cos ratio. So it's similar to the first one. It's still cos, but remember, it's cos alpha, cos beta. Now that because on the left-hand side, it was a plus sign, then on the other side, then we put what? A minus sign. Remember that. And remember that it's always cos, sine. Right. Okay, let's move to the next one. Okay, these are the two compound angle formulas for the sine. Remember that they are compound angles because they are dealing with more than one angle. There are more than one angle in one ratio. You see that is the cos of alpha minus beta, the cos of alpha plus beta. So you have got two angles in one ratio. That's why we call them compound angles. So the name compound angles has been derived because in the ratios are using two angles. Okay, now we move to the we will be required. Okay, Apiwa is asking a question. Will we be required in the exam to prove these formulas, or we only need to know how to use them? Okay, you won't be able to prove the formulas, but you will be required to use them in the problems. Basically, you'll not be asked to prove the formulas. You will be required to apply them when you solve problems up here. So you will see when we solve problems, how do we use these formulas? But you will not be required directly to prove that this is equal to that. You will only be required to apply them to prove the problems. I think that answered your question, Apiwe. Thank you so much. Okay, let us proceed. All right, you will see that in this case, I only address the two compound angle formulas for the ratio cosine. Okay, let's look at the compound angle formulas for sine. Let's go to sine now. Right? Okay, that is the sine. So the sine of alpha plus beta, remember, is a compound angle. The fact that it's a compound angle, we are dealing with two angles. So that is the sine of alpha plus beta. Look what happens on the right-hand side. It becomes sine alpha cos beta. The sign was a plus sign on the left. On the right, it's also a plus sign. So when it comes to the sine compound angle, the sign stays the same. You see, on the left, it was a plus. On the right, it's also a plus. It's very important that you identify this so that in the exam, you don't waste time looking at the formula sheet now and again. At least have an idea that, okay, with regard to sine, the signs are the same. And remember, with regard to the sine compound angle, it's sine followed by cos, cos followed by sine. So it's very important that you know this so that in the examination, you don't spend most of the time looking at the formula sheet. All right. Okay, that is the compound angle formula for sine. But in this case, remember, we are using the plus sign. Okay, you can guess now what's going to be the compound angle formula for sine if we are using minus. So like in this case, if now I'm using minus, say for example, is now the sine of alpha minus beta. What do you think the answer will be? Remember to post your answers on the chat box. What do you think the answer will be? For this one, we said is sine of alpha plus beta. So the answer is sine alpha cos beta plus cos alpha sine beta. What do you think the answer will be? You can write down the answer in the chat box. If now we change the plus sign to the minus sign. Okay, somebody has posted the answer. Let me see. Quirin sine theta sine beta. That's correct, Quirin. But the other side is not correct. I think that's the typing error. Quirin said it's going to be sine A sine B. Okay, that is correct. Michali also has responded. If it's a minus, it's sine A cos B cos A sine B. That's very good. So Quirin, you must just correct on the last term there. It should be cos A sine B. I think you made a mistake when you were trying to type there. All right, Quirin. Remember for the sign, Quirin, the sign they change is sine A cos B. I see your answer here says sine A sine B minus cos A cos B. This one is the compound angle formula for cosine. All right, Quirin, thank you so much. You realized your mistake. Thank you so much. Thank you for noticing that. Okay, now, okay, let's see the compound angle formula for the sine of alpha minus beta. It's very important that at least you know this by heart so that when you are in the exam, you don't waste that much time looking at the formula sheet. Okay, that will be the compound angle formula for the sine of alpha minus beta. And as you can see in this case, if it's a minus, remember, then it stays as minus, like in this case. But with regard to the cos compound angle, if it's minus, then on the right hand side it changes to plus. And remember also for the cosine, it's always cos sine sine. But for sine, it will be sine cos sine. Okay, thank you so much. Okay, those are the 4 compound angles that you need to know up to so far. Those are the 4 compound angle formulas that you need to know. I'm presenting this to you so that when we solve problems, already you have got the formulas. Then for you, it's just to apply the formulas. All right. Okay, thank you so much. I'm just erase that. Okay, let's move on now. Okay, Okay. We discussed the compound angles. And I said that the compound angles are referred to compound angles because we are using two angles in one ratio. You have seen that. The cos of alpha plus beta, the cos of alpha minus beta, the sine of alpha plus beta. You see that always there are two angles. Now the double angles. The name says it all. Double angles, double angles. It means that the angles are being doubled. And then we have got only two double angles, one for sine and one for cosine. One for sine and one for cosine. Okay, the first one is the sine of 2 alpha. So it's a double angle. You can see that is sine of 2 alpha. So it's a double angle. That is why it's referred to as a double angle. Like here, you see that it is a double angle. The sine of 2 alpha, the angle has been doubled. You see this alpha, it has been doubled. It's 2 alpha, so it is a double angle. Remember, the sine of 2 alpha will always be equal to 2 sine alpha cos of alpha. Remember, it's very important that you remember this in the examination so that you don't take time looking at the formula sheet. Remember, we don't have enough time in the examination. So this double angle for sine is 2 sine alpha cos alpha. Here, there is one thing that I would like to show you here. Remember, here, you can divide both sides by this 2, which is on the right-hand side. You can divide by these 2, both sides. You see the 2 on the right-hand side. I can divide both sides by these 2, but you can never divide by the 2 on the left-hand side. Remember that one. With this one, you cannot divide with it, but you can only divide by the 2 on the right-hand side. So if you do that, then you end up with the sine of, I'm just gonna write it here, you're gonna end up with the sine of 2 alpha. Remember that I've divided both sides by 2, so it will be divided by 2. And then I'll be left with what on the other side? I'll be left with sine of alpha. I'm gonna just write it like this, the sine of alpha. And what else? The cos of alpha. The cos of alpha. So that's what you will be left with. Okay, I've just said theta here, it should be alpha. You see, this is very important, and then you will need it when you solve some of the problems. That, for example, sine alpha cos alpha is the same as sine 2 alpha all divided by 2. And please do not be tempted by trying to cancel the 2's here. We cannot cancel these 2's here. Remember that, because this is just one angle. That is one angle. So the 2 here shouldn't be separated. All right. So that is the double angle formula for sine. And remember, for the double angle formula for the sine, you can divide both sides by 2 to get sine alpha cos alpha is equal to the sine of 2 alpha divided by 2. Okay. All right. So I'm just gonna clear that and then move to the next formula, to the next double angle formula, which is the cos one. Remember I said you'll have sine, you'll have cos. Like the compound angles, you had cos, you had sine. Okay, that will be the compound angle, the double angle formula for the cosine. So it says that the cos of 2 alpha, the cos of 2 alpha, as you can see here, it will be equal to cos squared alpha minus sine squared alpha. Right. But now here, remember yesterday, what did we say? We said we said, okay, you can tell me the answer. You can tell me the answer that, what did we say yesterday? We said sine squared alpha plus cos squared alpha. Please type the answer in the chat box. So I see somebody already has guessed what I'm gonna say here. We said sine squared alpha plus cos squared alpha equal to what? What is the value of sine squared alpha plus cos squared alpha? Okay, I see Michali said what? Thank you, everyone. You got it right. Asane, Michali, Orekhopote. So the answer is 1. Langanani, the answer is 1. That's very good. Italy, you also said the answer is 1. All right. Makhonchane, you also said the answer is 1. That is very good. All right, and that is something that you need to know by heart, that sine squared alpha plus cos squared alpha equal to 1. Now here, you will know that I can make sine squared alpha as the subject of the formula. So that will be cos squared alpha equal to 1 minus cos squared alpha. So if I make sine squared alpha, I can make cos squared alpha the subject of the formula. You know that cos squared alpha, it can be made the subject of the formula, and that will be 1 minus sine squared alpha. So it will be like this. Sine, I think you are familiar with that, sine squared alpha. You can also make cos squared alpha. You can also make sine squared alpha the subject of the formula. If you make sine squared alpha the subject of the formula, then your answer will be sine squared alpha equal to 1 minus cos squared alpha. Now, all this information that you gave me here can be used to get or to derive another formulas for the cos of 2 alpha. All right? From these 2 formulas that you gave here, we can derive another formulas for the cos of 2 alpha. Remember, cos 2 alpha we said is cos squared alpha minus sine squared alpha. But then, because of what I've just written here, you can get another 2 formulas that will also give you the cos of 2 alpha. Okay, let's see what we get if we use what has been handwritten here to get the 2 other formulas. I think some of you might be familiar with that. Okay, let's see which formulas we get using the ones that we have just discussed. Okay, that is the OR. That's what I have here. You see, cos 2 alpha can also be equal to 2 cos squared alpha minus 1. Do you agree with the statement that the cos of 2 alpha can also be 2 cos squared alpha subtract 1? So where comes this? What we did here is that we replaced sine squared alpha. You see sine squared alpha. We replaced it by what? By 1 minus sine squared, no, not sine squared, minus cos squared. This is cos squared alpha. Do you see? So if I replace sine squared alpha, remember sine squared alpha, from sine squared alpha plus cos squared alpha equal to 1. Sine squared alpha equal to 1 minus cos squared alpha. So you see, if we substitute here, then you will get cos squared alpha minus times minus will give you a positive sign. So you'll end up with cos squared alpha plus cos squared alpha, which gives you 2 cos squared alpha minus 1. So in the exam, you must know that you can also write cos 2 alpha as as 2 cos squared alpha minus. Yeah, that is very good. 1 minus cos squared alpha. Asane, yeah, you got it right. Yeah, that is the substitution. That's very good. We do that by substitution. That's very good, Asane, for getting that correct. All right, let's look at another formula. Remember here I replaced what? I replaced sine squared alpha. I replaced sine squared alpha by 1 minus cos squared alpha. But now, if I replace cos squared alpha, if I replace this one, which formula will I get? If now I replace cos squared alpha, if I replace cos squared alpha will be replaced by what? From cos squared alpha plus sine squared alpha equal to 1. Cos squared alpha can be replaced by what? Okay, let's see. Kiasan, you said 1 minus 2 sine squared alpha. Yes, that's very good. That's the next formula. That's the next formula. If you see that next one or that one. All right. So for the cos of 2 alpha, it's just one formula. It's enough for you to know this one formula, this one, the basic one, cos squared alpha minus sine squared alpha. But it will make your calculations easier if you also know that cos 2 alpha can be 2 cos squared alpha minus 1. Cos 2 alpha can also be 1 minus 2 sine squared alpha. So that will help you when you solve problems. So it's enough to know that cos 2 alpha equal to cos squared alpha minus sine squared alpha. But it is more helpful if you also know that this cos 2 alpha can be written as 2 cos squared alpha minus 1, or it can be written as the cos 2 alpha can also be written as 1 minus 2 sine squared alpha. All right. Okay. So these are the double angles, the one for sine and the one for cosine. Remember, we said that the one for the sine of 2 alpha will be 2 sine alpha cos alpha. And remember, you can divide both sides by 2 to get sine 2 alpha divided by 2 equal to sine alpha cos alpha. And then we also talked about 2 cos alpha, not 2 cos alpha, cos 2 alpha. Cos 2 alpha is the same as cos squared alpha minus sine squared alpha. And remember the breakdown also in this case. All right. Okay, let's now move to problems and see how do we apply compound angles and double angles in solving problems. Remember, the compound angles and the double angles, you must know them because when we solve problems, we use them. Remember, we will also use the knowledge that we acquired yesterday. The knowledge that we acquired yesterday, you shouldn't throw it away. We're going to use it in today's lesson. All right. Thank you so much. All right, let's go to activity 1. Remember, I've said with the questions, what is very important? Read the statement. It's very important that you read the given statement. Why is it important that you read the given statements? Because some of the answers are lying in the given statement. Okay, that's our given statement. That's our given statement. I can hear you now. You are reading the statement. Everybody's reading the statement now. I can hear you loud and clear. Given, what are we given? Cos of alpha minus b. You are given that cos of alpha minus b equal to cos A cos b plus sine A sine b. That is what is given. Now, the question is, use the formula for cos of A minus b. They say, use this given formula of cos of A minus b. It is given to you. Now, you need to use the formula of cos of A minus b to derive the formula of sine of A minus B. Somebody asked me if the formulas, you will be required to prove the formulas. So that is one way of asking the questions. They won't directly ask you to prove the formula, but the question can be replaced in this format. And it is very important that you grasp this very well, because in the examination, it is possible that you might have something like this. You are given the cos of alpha minus B. And what is the cos of alpha minus B? It is given that the cos of alpha minus B is cos A, cos B plus sine A, sine B. Use the formula for cos of A minus B to derive a formula for sine of A minus B. Now, what is the relationship between sine and cos? What is the relationship between sine and cos? How is sine and cos related? Yes, Henry, 90 degrees. Henry, you are very good. 90 degrees, they are co-function. Joy, that's very good. They are co-functions. That's very good. So the relationship between cosine ratio and sine ratio is that they are cos functions. They are co-functions. That's why one function is sine, the other one is cosine, because they are co-functions. All right. So it means that, therefore, to answer this question, cos in terms of sine, we must use the co-functions. Like Henry has said, we need to use the 90 degrees because co-functions have to do with 90 degrees. Remember that. Remember that very well. Okay, let's see how do we do the solutions. We already know that we are likely to use the co-functions. And remember that this, in terms of the examination, already at least you have got an idea. That 90 degrees that you are using there, at least 1 mark will be given to you. All right, let's hope some of these questions, they come as we are discussing them like now. All right, let's get to the first step, the solution. Do you agree with that solution there? Do you agree with that? For the solution, remember we are finding what? They say use the formula for cosine to derive a formula for sine. So we are deriving a formula for sine. That means that on the left-hand side, we must have sine of A minus B. That is what we must find in the question, sine of A minus B. Do you see the 90 degrees that Henry referred to? Henry and Joy, they talk of co-functions. So the sine of A minus B will be the same as cos of 90 degrees. That's your co-function. Is 90 degrees minus the angle. Remember, we are using these guys. Is the sine of, I'm just going to write something here so that you can see. Say, for example, we have got the sine of theta. We know from yesterday that the sine of theta is the same as the cos of, just going to write here, that's the cos of 90 degrees. These are co-functions. I'm just going to remind others, those that might have forgotten this, it's 90 degrees. I'm just going to write, please, don't mind my handwriting. Remember from yesterday's lesson, we said this. Yeah, that's very good. We said this. We said that the cos of 90 degrees minus theta. You remember this statement? We discussed it yesterday. The cos of 90 degrees minus theta is the same as sine theta. So now here, we are expanding that knowledge. Instead of theta, instead of this theta here, we have got what? We have got A minus B. is a compound angle, because now we are dealing with compound angles. They are compound because we are dealing with two different angles. Is the angle A and the angle B. Now your theta is now a compound angle. It's A minus B. So that means on the other side, the 90 degrees will be there. That's the 90 degrees, which you see here. But it's a minus sign, so it's a minus sign. And where is your angle now? Your angle is now A minus B. But in the original, we said 90 degrees minus theta. But in the double angle, is a double angle. It's A minus B. So that's why we have got the cos of 90 degrees minus our compound angle, which is A minus B. It might seem frustrating to other learners, but if you take it from this side, that the sine of theta is the same as cos of 90 degrees minus theta, which implies that your theta is now a double angle in our question. All right. Now I'm just going to show you the next step here, because it is still linked to this. Let me clear out all these weights. There you are now. Do you see what I've done here? Is the sine of alpha minus beta or minus b. The sine of A minus B, we said we use cofunctions, is the cos of 90 degrees minus the double angle, the compound angle A minus B. Put it in bracket. Now we say that will be the cos of 90 degrees minus A. So I'm grouping the 90 degrees and the A. I'm putting this together. The 90 degrees and A comes together. Then that will be the minus sign. Is that minus sign there? And then the minus B, that's the minus B. We keep it there. And now this, the cos of 90 degrees minus A minus B, if you look at it carefully, is the same as the compound angle of cos of, say, alpha minus beta. If you see that, this formula here is the cos of your alpha is now, do you see the alpha there? Your alpha is now 90 degrees minus A. So my alpha is now 90 degrees minus A. This minus here, it will be that minus here. But now your B is minus B, your beta is minus B. I think it's very important that you notice what is happening here. Here I'm saying the 90 degrees minus A is now your alpha. That's very important, because we are dealing with compound angles. That's why then you'll always see two angles being grouped together. The 90 degrees minus A is your alpha. This is the minus sign. So the minus sign comes here, comes there, comes here. And then your minus B is the beta. So you have got, actually here you have got the compound angle of the cosine. So the cos of alpha minus beta is this one here, is that one there. It's just that here now, what is going on here is that we are dealing with double angles. And what is the value of the cos of alpha minus beta? Yolanda is saying, why did we choose A instead of B? Why did we group 90 degrees minus A and not grouped it with 90 degrees minus the B and then left the A? I think here you can do anything, it's just that we started with A, so that's why then we need A to appear first. because in the formulas we are starting with A, so we group with A because we want A to appear first. That is the only reason that we are doing in this case, Yolanda. Will it still be correct if I say, Michali says, will it be correct if I group minus A plus B? Okay, Michali, it might be a problem if you group minus A and B. Michali is saying, what if now we group, what if now, I'm just gonna erase my handwriting there. For Michali, let me start by answering Yolanda. Yolanda, you said, I think that is I think you understood what I've said, Yolanda, that I chose A instead of B because I want A to appear first. I want A to appear first because in the formulas A appears first. So that's why then I want to group this one. Now another question is asked by Michali. Michali say, will it still be correct if I group minus A plus B? So Michali is saying, will I still be right if I group minus A plus B? Michali, it will be a problem because you will be having two unknowns. It will be a problem if, say, you group minus A plus B, meaning that you remove the brackets, Monsieur. It will be like minus times A is minus A, minus times B is plus B. So you'll be saying minus A plus B. So you'll be having two unknowns. So that will be a problem. You won't go any further. But then if I group 90 degrees and another variable, it will be better because I can work, I will know the value of 90 degrees. I think, Michali, I've answered your question. Thank you so much. Then Asane is saying, could one multiply the negative into the minus B brackets to make it plus B? All right. Now, Michali, okay. Then one other thing, you see what the Asane is saying. The question for Asane says, yeah, I think, guys, I'm very happy that you are asking these questions because this formula here is confusing and it's very important that you ask these questions. These questions are very important. Remember, understanding is very important. It will be easier for you if you understand it now. In the examination, you will be able to answer the questions correctly. Understanding is very important. Okay, yeah, I see what you are referring to, Asane. Asane is saying, will it be correct if we do this? Let me write it down here. I must actually write down what you are asking because that is very important. So Asane is saying, will it be correct if we say the cos of, I'm gonna do that, 90, so let me see what you have written here, Asane. You said 90 degrees, 90 degrees, yeah. Asane said this. It's very important because this step is very important because if you miss this step here, you don't write it correctly, you would have messed up everything and it might be difficult for you then to proceed going further. Then you say, this must be plus. Always forget to write. Okay, gentlemen, ladies and gentlemen, this is plus. I'm just gonna put a plus here. Then you said B. All right. So that is the question that Asane is asking. You all see that? You see, this step here is very important. Asane is saying, wait, what is wrong if I group it like this? What is wrong if I group it like this? Will it still be okay? It's going to be a challenge in this case. Why is it a challenge? Because in our minds, we know that on the left-hand side, it's a minus sign. Do you see the minus sign? So this side also, the angles must be separated by the minus sign. Because remember, when you prove, you are proving towards the answer. Already you know the answer. Already you know where you must arrive. So the route that you take, it must be the route that will take you to the correct answer. So because on the left-hand side, I've got a minus sign separating A and B. So on the right-hand side also, between the two angles, I must have a minus sign and not a plus sign. So that is why it might be a challenge if you are following this route of the plus sign, because it means that you are now erasing that minus sign that we wanted in the middle of the expressions. We need this minus sign, so we cannot do it in this way, unfortunately, because we won't be able to arrive at the destination. Okay, Apiwe, thank you so much. Thanks, Apiwe, thank you. All right. So this step is very important. This step is very important, and I'm happy that you are asking these questions, because I also remember when I was still a student that this step here, if I make mistakes at this step, then everything just goes wrong. So firstly, remember, we group 90 degrees and then A, because we want A to appear first. All right. Remember also, we cannot group A and B because we will be having two unknowns. Two unknowns. And then if you have got two unknowns, then you can't go any further. So you rather have at least one known, because the value of 90 degrees can be calculated on the calculator. So I'll have one unknown here. I've got one unknown on the other side. All right. So this step, my learners, it's very important, and I'm happy that you asked all these questions. All right. Okay. Okay, let's move now to the next. And this is a typical question that the examiners like when it comes to the compound angles. And remember, if you understand one question, this confidence, you can use it in other questions. This knowledge, you can use it in other questions. Okay, let's now move on. Let's proceed with the proof. All right. Okay, what's happening here? Which rule is this one? Which rule is this one? The one that I've just shown here. Which rule is this one? What do you notice here? Please go through that, then tell me, type in the chat box. Which rule did I use there? This thing didn't see. Okay, let's see. Somebody says cos compound, double angle, cos compound, double angle. Mikali says cos compound, Apiwe, cos rule. Compound angles Apiwe, Miponi, cos of A minus B. Mikali, Henry is the sine plus double angle. All right. Okay. Thank you so much for your answers. All right. The rule that I've used here, I see there is also an answer in your compound angles, Asani. Yes, I've used the cos rule, the compound angle rule. It is not the double angle rule. I saw there is one student, there is one learner who said is a double angle rule. One learner said is a double angle rule. Let me just see. Okay, I'm just gonna close that. It's a double angle rule. The sine rule, Mihlali. Okay, that's very good. That's compound angle. This, remember, double angles are like double angles. I see somebody gave the answer like double angle. Double angle, like I've explained, is like sine of 2 alpha. So this is a double angle because we doubled the alpha. But this one here is a compound angle for cosine, because the expression here was cos. So I used the formula of the cosine to expand that. You still remember the formula for the cosine? You still remember the formula for the cosine? You still remember what did we set about the cos of, say, A minus B, A minus B. You get this in the formula sheet, but it's very important that you also remember, because if you see clearly here, this is the same as that. Okay? This one here is the same as the one that I've written below. That thing here is the same as that. The only thing is that your first angle is A, but here the first angle is 90 degrees minus A. So this is the same as that. But now remember, we said, what is the value of the cos of A minus B? We said the answer is cos of what? Cos of A, cos of B, cos of B, and that will be in the formula sheet. Oh, it's here already. Okay, there's no need to write that here. That's what we have here. That's what we have there. Okay, I see Langanani, you gave me the answer. That's very good. That's very good. So that's what we have there. I'm just gonna erase what I was writing. So this thing here, this, you see that, is the same as that. So now I'm expanding this one. I'm expanding that using what? Using what was given. So instead of A, I've got 90 degrees minus A. So what I will do is that where there is A, where there is this A, you see that A, where there is this A, I'm gonna put 90 degrees minus A. You see, where there is A, I will just put 90 degrees minus A. So that will be 90 degrees minus A, because my A now has been substituted with 90 degrees minus A. And what is your B? B has been substituted by minus B. So where there is B, I'm gonna put minus B. I'm gonna put the minus B. That's the minus B. I'm gonna put the minus B. So this is just substitution. That's just substitution. So that side, that first part there is correct. Where there is, because this is the one angle, 90 degrees minus A. 90 degrees minus A comes first. That was A, that's now 90 degrees minus A. What is your second angle? Your second angle is now minus B, minus B. Your second angle is now minus B. It's very important that you notice that. You see here is cos A. But now my A is what? Is 90 degrees minus A. So 90 degrees minus A. So where there is A, I put 90 degrees minus A. It's like saying the substitution. It's like after you have written this, someone can say, I will know that A, where there is A, I must put what? 90 degrees minus A. There you are, 90 degrees minus A. Where there is A in the given formula, I'm gonna put 90 degrees minus A. That's what you have, correct? And where there is B, I'm gonna put what? Where there is B in my given formula, I'm gonna put minus B. Where there is B, I'm gonna put minus B. Guys, I think this formula here, you need to understand it very well. So that is what I've said here, that this is the cos of A minus B, the cos of 90 degrees minus A minus B. But now we are saying the A is 90 degrees minus A. A is 90 degrees minus A. B is minus B. So on the right-hand side here in the given formula, on the right-hand side in the given formula here. Where there is A, I'm going to put 90 degrees minus A. Where there is B, I'm going to put minus B. So that's straightforward. Cos, what's A? 90 degrees minus A. Cos, what's B? Minus B. Plus sine, Sine, what is A? 90 degrees minus A. Times sine, what is B? B is minus B. So I've expanded that. Because remember, even in the question, they said use the cos of A minus B to derive the formula for sine minus A. So after you have substituted everything, then you will say my A is 90 degrees minus A, my B is minus B. Right, then let's go on. Okay, that is the substitution that I was talking about, whereby the A is now 90 degrees minus A. So where I see A, I just substitute it by 90 degrees minus A. Where I see B, I just put minus B. All right, then now let's proceed now to the next step. What will be the value of cos of 90 degrees minus A? What's the answer? What's cos of 90 degrees minus A? Cos of 90 degrees minus A equal to what? We discussed that yesterday. Sine A. Henry Good, sine A. Mihlali, sine A. Moiponi, sine A. Apiwe, sine A. That's very good. Italy, sine A. That's very good. Because it's a co-function. Shamila, you also say is sine A. Langanani, you also say it's sine A. That's very good. That's very good. That's very good. I see Colossa, Jaji, very good, Jaji. You said it's also sine A. That's very good because it's a co-function. Remember that it is a co-function. Remember, it's a co-function, so it should stay like that. Asane, you also say it's sine A. That's very good. It is a co-function. These are the things that you need to know, guys. That's very good. I'm happy that you are following here. That's very good. All right. Now, what's going to happen is that I'm going to replace cos of 90 degrees minus A. I'm going to replace cos of 90 degrees minus A by what? By sine A. Because I know that. Okay, obviously, here you know that the sine of 90 degrees minus A is cos A. It's replacement. All right, we are just going to substitute there. These are co-function. Cos of 90 degrees minus A. Because of the 90 degrees, the co-function of cos is sine. The co-function of sine is cos. Now, give me the answer to this one. The cos of minus B. What do you think the cos of minus B? The answer will be this one. What do you think the cos of minus B will be? We discussed this yesterday. All right, I see the answers are coming. The cos of minus B, that will be cos B Mitali, Euphrasius, Haldesos, cos B. That's very good. Yeah, people are getting Italy, Gertrude, cos B. Gertrude, thank you so much. Joyce, thank you so much. It's cos B. Why do we say the cos of minus B is cos B? Because remember, we said yesterday that we assume that all the negative angles are in the fourth quadrant. So once it's minus B, it means minus B lies in which quadrant? The fourth quadrant. And we know that cos in the fourth quadrant will be positive. Asane is saying yes, the fourth quadrant. Yes. And then sine of minus B, what do you think sine of minus B will be equal to? Sine of minus B, what's the answer? We're going to replace sine of minus B by what? We're going to replace sine of minus B by what? Langanani minus sine B, Mihlali minus sine B, Euphrasius Haldezos minus B, Asane Api, that's very good. Mkwanazi Apiwe minus B, Mihlali minus B, that's very good. So we replace that, we will replace sine of minus B by minus sine B because all the negative angles are in the fourth quadrant. The assumption, we assume the fourth quadrant. Okay, therefore the next step, you have actually written the next step for me, and that will be our next step. So you can see that now, in this case, we have said the cos of 90 degrees minus A is sine A, the cos of minus B is cos B, and then here is minus. Where comes this minus? Because we said sine of 90 degrees minus A is cos A. But remember, we said the sine of minus B is minus sine B. Ne? Minus sine B. The sine of minus sine B is minus sine B. So we said that minus of sine B by this positive is minus, and that now ends our proof, I think. Let's see what's coming now. Yeah, that ends the proof now. So you can see now you have the formula for sine of A minus B. So the sine of, you're just gonna write it here, but because I wrote the equal signs, it means that the left-hand side equal to the right-hand side, which is minus, and then here I will have A, B. That is the same thing. So we stop there. So you have proved that. That's very good. Thank you for your contributions. That's very good. So that will be the answer. All right. Thank you, Apio, for saying that. Okay, that will be the answer to that question. And remember, our question was. Remember, what was the question? The question was, given cos A minus B equal to cos A cos B plus sine A sine B, we are given this, then you must use the formula for cos of A minus B, meaning you must use this formula to derive a formula for sine of A minus B. And then in our minds, we know that cos and sines are co-functions. So quickly then I will write cos of 90 degrees minus the compound angle. Remember, you minus the whole angle. And then from there, the grouping in this step is very important. And I think we dealt with that in detail. You'll group 90 degrees with minus A and then minus the minus B. And then from here, you'll notice that this now, you can use the rule which was given to you, you expand. And then after expanding, you must know that the 90 degrees makes this cos to be sine. The minus is in the minus B is in the fourth quadrant. The minus B is in the fourth quadrant. Then you arrive at your final answer. Okay, let's proceed to the next activity. Let's proceed to the next activity now. Remember, with these activities, it's very important that you read the question. Questions are very important. Okay, activity 2. Okay, let's read the question. Here everyone is reading the question. If sine 36 degrees cos 12 degrees equal to P, and cos 36 degrees sine 12 degrees equal to Q. So the variables here are P, that's your P. You have got also Q. So P is given as sine 36 degrees cos 12 degrees. So that's the P. P equal to sine 36 degrees cos 12 degrees, while Q is cos 36 degrees sine 12 degrees. Then it says, without the use of a calculator, determine in terms of P and Q the value of the following. The value of sine 48 degrees. Determine the value of sine 24 degrees. So we have got two questions that we must answer here. Sine of 48 degrees and sine of 24 degrees. But our answers must be in terms of P and Q. What they mean here is that your final answer must contain the letters P and Q. That is what they mean when they say determine in terms of P and Q. It simply means that your final answer, or you must leave your final answer containing the variables P and Q. All right. Now, if you look at what is given here, you look at what is given carefully here. It's sine, cos. See? Cos, sine. Ne? And you are given these numbers, the sine of 48 degrees, the sine of 24 degrees. All right. Okay, let's start with number A. Number A, we must find the sine of 48 degrees, but your answer must contain P and Q. Now, you are given 36 as well as 12. All right, guys. Now, tell me, how will you write 48 such that it has got both 36 and 12? When will I find 48 using 36 and 12? And why do I say 36 and 12? I'm saying 36 and 12 because 36 and 12 are what is given. Okay, I see. Italy says you will say 36 plus 12. Good. Asane, 36 plus 12. Apiwe, 36 plus 12. That's very good. That's very good. I will say that. And why do I say 36 plus 12? Because I'm given 36 and what? And 12. You see? So you think of how you can write 48. 48 in terms of what? In terms of 12 and 36. I'm using specifically 12 and 36 because this is what is given. We know very well that 48 can be like 2 times 24. It can be like 40 plus 8. It can be any combination of numbers. But our focus here is 36 and 12. And why do we use 36 and 12? Because 36 and 12 are the numbers that are given. So it means that here you need to stop and think a bit. How will I get 48? How will I get 48? So you can only get 48 in this case if you say 36 plus 12. I see Miponi already has got the final answer. Thank you so much, Miponi. You are doing very well. The final answer will be, okay, Miponi got the final answer. And Miponi, thank you so much. The final answer is correct. I don't know if others also have done the problem and then they got it correct. That's very correct. Okay, I see Mikhali also, yes, the final answer, you got it right. I'm not, okay, also Mikali, yeah, you got it right. The final answer is correct, yeah. The majority of you are doing very well. So I see that you already got the final answer. Okay, from here now, that's, then what do you notice now? This is the compound angle formula for sine. Do you know what is sine of alpha plus beta? Sine of alpha plus beta is sine alpha cos beta plus cos, plus, it must be plus the cos of alpha, the sine of beta. So our next step will be that. Remember the sine formula? The sine of 36 degrees plus 12 degrees is this one. That's very good. Is that one? Do you see that? That is very good. That is the thing here. That's the thing there. Yeah, up here you also got the final answer correct. Thank you so much. Amogelang, that is the final answer is correct. Very good, Amogelang. Asane, the answer is correct. Thank you so much. People have already got the final answer. That's very good. You must always be in front of your teacher, right? So the sine of alpha plus beta, we said is sine alpha cos beta plus cos alpha sine beta. Very good. So we expand this using that formula, all right? I'm just gonna erase that and then expand what is given. Expand what is given there. That's the expansion. You see that your alpha is now 36, your alpha is now 36, your beta is now 12. So where there is alpha, I'm gonna put 36 because now alpha is 36 and then beta is now 12. So where there is beta, I'm gonna put 12. Where there is alpha, I'm gonna put 36. Etal, so the answer etal is correct. You got it right also. The final answer is correct, etal, that's very good. So now after expansion now, that's the expansion. So that will be P plus Q. So sine 48 is now P plus Q. Thank you to everyone who gave me these correct answers. And then if I got P plus Q because now sine 36 cos 12 from what is here, it's equal to P. You see, sine 36 degrees cos 12 degrees is P, is that one? Yeah, all right. And then you know the value of cos 36 degrees sine 12 degrees. Here it is, it's the Q. This guy here is Q. So that's why the final answer is P plus Q. So Asane already did the next problem. Thank you, Asane, is correct. The others also, please try sine 24 degrees. What will be the value of sine 24 degrees? Try it and then post the final answer. Miponi P minus Q. Oh, that's very good. That's very good. That's very good. Miponi. Okay, the others are posting their other answer here already. Henry also got it right. Mbale, Apiwe, Mikali also got it right. Miponi, okay, Miponi got it right also. And then the others, what are you saying? What will be the final answer there? For the sine of 24, use the numbers 36 and 12. 24, when will I get 24 if I use 36 and 12? Okay, so let's see the solution to number B. See the answers are coming. Haldezos, yes, you'll say 36 minus 12. You'll get 24. That's very good. That's very good. I see also Joy there. Colossa Jaji also, you'll say, yeah, the final answer is correct. Yeah, you got it right. So I'm just going to go through that final answer now for number B. Let's now do number B. Okay, number A is fine. Ne? So everybody is happy with number A. The sine of 48 degrees, the answer is P plus Q. All right. Now let's go to the next one. The sine of 24 degrees. I'm going to say normal there and then go to the next one. Okay, that's the question. Amogelang, yes, the answer is correct. Aldezos, yes, number B, you got it right. Thank you so much for your answers, for the good answers. All right, here I've just posted the question again. This is what was given. We want the value of sine 24, and then others have said already is 36 degrees minus 12 degrees. I think you all agree with that. And then from there, what did we do? You must expand this. You see that is a compound angle. Remember, once you have got two different angles in a ratio, quickly move to compound angles. Because you have got 36 and 12, so quickly you expand by compound angle. That's we will expand it by compound angle. Then the expansion then give us, oh no, I didn't click here. I must click here. And then to move to, okay, that is the answer. That is the expansion. That's the expansion. It's a compound angle for sine. Negative stays as negative. Then you just say sine, cos, sine. In the formula sheet is there, but it's good if you know it by heart because you want to waste time looking at the formulas. You'll just substitute, and then you can see that if I do that, if I expand this, you get that. All right, that's the expansion. Everybody knows that. And then the final answer. Let's get to the final answer. Good. P minus Q. Langanani, you got, yeah, sine 36 cos 12, cos 36, and that's very good, Langanani. You're doing very well. You're doing very well. You're doing very well. And that is the answer. So that means that we will say the sine of 24 degrees in terms of P and Q is P minus Q. You see that we didn't use a calculator here. We didn't use a calculator. We're just doing calculation. William, very good. William Kafela, the answer, P minus Q. Very good. Very good. You got it right. All right. So let's move to the next question, and let's see if there's a question regarding this, but I think that's the statement is very clear. Remember, if you're given these types of questions, check what was given and then write down the answers in terms of the numbers that you are given here. Don't forget that. All right. Let's move on. Let's move on. So I must click here now so that I can move on. Activity 3. Read the statement. I can hear you loud and clear. People are already reading. Please read it loud so that I can hear you. Given that the cos of 2b equal to 3 divided by 5. That's what I have there. Cos 2b is 3 divided by 5. That's cos 2b. Already here, what do I see? A double angle, ne? Cos 2b. We doubled must be here. Cos 2b is a double angle. And B is from 0 degrees to 90 degrees. This 0 degrees to 90 degrees means B is in which quadrant? Thank you. Joy, first quadrant, yes. Apiwe, first quadrant, Italy, Miponi, first quadrant. That's correct. Aldezos, first quadrant, Azane, first quadrant, that is correct. So your B lies in the first quadrant, that's good, because it's between 0 degrees and 90 degrees. So whatever you are doing, you must make sure that the B, finally, the B must be in the first quadrant. And what do we know with the first quadrant is that all the angles are positive, all the angles are between 0 and 90 degrees. And from this question, we already in our mind, we suspect that we're gonna use the double angles because here you are given a double angle. And we discussed this. Remember, what is the cos of 2 alpha? The cos of 2 alpha is cos squared alpha minus sine squared alpha. Remember that, okay? Then they say determine without using a calculator the value of each of the following in their simplest form. So we need to determine the values of each of the following in their simplest form. Number 1, the value of cos B. What will be the value of cos B? The value of sine B. What will be the value of sine B? From what is given, what will be the value of the cos of B plus 45 degrees? Yeah? How do we go about this? Let's see. How will you do this? Okay. Okay, let's go through the solutions. Just gonna remove this in my way, sitting in my way. This thing is in my way. Just gonna put it there. And then put this one also here. Okay, now I can work clearly. Okay, we know that we are given the cos of 2b is equal to what? 3 divided by 5. All right. Now, what did I do here? I replace cos 2b by 2 cos squared b minus 1. That is correct, isn't it? Yeah, you can make a sketch. You can make a sketch, but here it's just going to be a problem, Ital, here. If we make a sketch, you see the problem with the sketch here is that is that the problem with the sketch here, Ital, is that in the sketch, your angle is going to be 2B. Italy. In the sketch, your angle is going to be 2B. And I don't think that will work here, because in the sketch, I carry you're going to put this, say, in the first quadrant. If you use the sketch, as Italy is suggesting here, then let's see the problem with the sketch now. It might be here if we immediately use the sketch here in the first quadrant. Your angle here, Italy, is going to be 2B. If we use the sketch, this is going to be 2B. And then if you put 2B here, and then cosine is 3 divided by 5. I get it. It's going to be like this. And then now, okay, you'll use Pythagoras, and then you get this side here. But now the problem is that we must find cos B. So from this sketch, you're going to say cos of what? 2B and not B. So the angle, unless if we can, so in the sketch here, you must have a B and not a 2B. So that's why then it might be a challenge to immediately use a diagram here, because the angle here is 2B. You see, if the angle was only cos B, then here in the sketch was going to be B, and then we can directly use the sketch. But here now, the challenge is going to be when you try now to find the values. When you try to find the values, you're going to have sine B, but in the sketch is 2B. So the best thing is to do the transpose, as RP was suggesting. Thank you so much, Tali, for understanding. So that's why then we do the substitution as RP is suggesting, RP Mkwanazi is suggesting there. Okay, so using the sketch here might not help us that much, because as you can see in that sketch, you're gonna must put 2B, and once you plug 2B, how are you going to go about now using the one angle which is your B? So what we can do in this case is to expand cos 2B, expand cos 2B quickly, and then you get 2 cos squared B minus 1. And I see Joy already got the answer. Thank you, Joy. You got the answer as that. Thank you. Yes, we transpose, then divide by 2. That's good. We will divide by 2. That's our next step. I'm happy that you are doing this with me. Okay, then you have got cos squared B equal to 4 divided by 5. Then you square root, you put the square root both sides. Then you have got that which is 2 divided by the square root of 5. Then remember that here you want to include the negative number because the B must be in the first quadrant. So the final answer, cos B, is 2 divided by the square root of 5. And then 2 divided by the square root of 5 definitely is in the first quadrant. All right. So now, remember the answer that you got in A, you might use it in B. So don't throw it away, because you might use it in the following question, in the question that follows. So let's look at the next question now. How will you find sine B? I think already so some people got that. Now we continue. Okay, you are given that. We must now find the value of sine B. How will you find sine B? You know cos B. You know cos B? You know the value of cos B already? I can do that. Sine squared B. It's 1 minus cos squared B. Okay, that is correct. Remember that cos B we said is 2 divided by the square root of 5. Okay. And I assume that you already know where comes this. This, remember, is that thing, sine squared B plus cos squared B equal to 1. Remember the one thing that we normally use. This one you mustn't forget, sine squared B. No, I'm just going to say sine squared A plus cos squared A plus cos squared A cos squared. That's cos squared A cos squared, or sin squared A plus cos squared B, we know that this is equal to 1. All right. So now, because they're asking me to find the value of sin B, so I must write down the formula that contains sin B, and that will be sin squared B, sin squared A plus cos squared B equal to 1. And then, but now because I'm finding sin B, so I make sin squared A the subject of the formula. I see Miponi here already got the answers. Joy also got the answers. Thank you so much. The answers that you got are very correct. They are very correct. You are very correct. Precious, you have got that answer there. Haldoses, I'm not sure if that answer is correct. Okay, but let's see what we get. Let's see what we get. The others, please continue posting the final answer. Continue posting the final answer. Okay, then we will have sin squared B equal to 1 minus 4 divided by 5. Do you see that? Why? Sin squared B equal to 1 minus 4 divided by 5. Because what we did in this case, it's 1 minus cos squared B. We know the value of cos B we said is 2 divided by 5. So if we substitute here, it will be 4 divided by 5. Do you all see that? And then the next answer, so sin B is 1 divided by the square root of 5. Yes, Apiwe, that's very good. Amokelang, that's very good. The answer is you said the square root of 5 divided by 5. That's very good. The square root of 5 divided by 5 is also very good, because you remember that we cannot leave the answer with the square root in the denominator. But even if I can't make square roots of my phone. Yeah, I see Haldazos. Yeah, it's difficult to make square roots on your phone, but Haldazos, you can just write square root of 1 over 5, like writing it in weight. Square root of, you write it like in weight. Like Miponi just wrote square root 1 over 5. Yeah, thank you so much. Yes, in weight. Yes, in weight. Yes, do it in weight. Do it in weight. Thank you. Thanks, guys, for getting the answer correctly to this one. Okay, let's move to the next question. Okay, let's move to the next one. I'm gonna click here now with that. Okay, the next question was to find the cos of B plus 45 degrees. What do you think we're gonna use here? What do you think we're gonna use here to find the answer to this one? What do you think we are going to use to find the answer to cos of B plus 45 degrees? What do you think we're gonna use here? How are we gonna expand this? The cos of B plus 45 degrees. A compound angle, Mikali, Joy, Asane. Yes, we're gonna use compound angle for cosine. Colossa, Jachi, you also say compound angle. Apiwe, you also say compound angle for cos. That is very correct. Remember in my introduction, and what I'm always saying is that once you see two different angles being added or being subtracted, quickly move to compound angles. Quickly move to compound angles or suggest compound angles. That's where we are now. And that is what I did here. So I expanded that. I just expanded the cos of alpha, the cos of B plus 45 degrees. It will be the cos of beta, the cos of 45 degrees, minus the sine of B, the sine of 45 degrees. And remember, if you forget this formula, the formula will be there in the formula sheet. But it's important that you know it so that you don't take time searching for these formulas. Right. Then after doing that, you can press your calculator, take your calculator, find the value of cos 45 degrees. You can find that on the calculator. What is the value of cos 45 degrees on the calculator? Now you can use your calculator. Remember, these are also special angles. You must know them by heart. But here we can assume the calculator. Let's find the cos of 45 degrees. using your calculator. Square root 2 divided by 2 appear, that is very good. Langanani, square root 2 divided by 2, that's very good. Square root 2 divided by 2. Yeah, Haldezos, yeah, you just write it like this. In weight, square root 2 over 2. Square root 2 divided by 2, Ital. That's very good. Yeah, that's, and then you get this on the calculator. And then that is what I got. And remember, we already know what is cos B. We already know what is cos B. We calculated the value of cos B in question A. Then cos, we said is square root 2 divided by 2. And then we already know most the value of sine B. The value of sine B, we calculated it in question B. The value of sine B here, we said sine B is 1 divided by square root 5, 1 divided by square root 5, or square root 5 divided by 5 is the same. You can write it as 1 divided by square root 5 or square root 5 divided by 5. And then your cos of 45 will be square root 2 divided by 2 or 2 divided by square root of 2. You get this on the calculator, which is very good. That's fine. Square root 2 divided by 2. Square root 10 divided by 10, Asane, that's our final answer. Others, what did you get as the final answer? Miponi, square root 10 divided by 10, that's very good. Mikali, square root 10 divided by 10, very good. Joy, also square root 10 divided by 10 is the final answer to this question. That's very good. You are doing very well, and we are happy that you are all doing so well. That's square root 10 divided by 10. Okay. So that is the trick of this question. And in this question, like I've done it here, it might be difficult to use a diagram. Yeah, if even myself at first, I thought that we can try a diagram, but in this case, the diagram cannot work because in the diagram, you're gonna put a double angle 2B, whereas we want the angle B only, all right? So not always that you will use a diagram. So in these questions, we didn't use a diagram, but we still arrived at the final answers as required. All right, activity 4. Let's look at question 4 now. Okay, let's read the statements to question 4. Let's look at question 4 now. If sine 24 degrees equal to P, express the following in terms of P without the use of a calculator. 1, cos square 24 degrees. What is the value of cos square 24 degrees? What's the value of sine 12 degrees, cos 12 degrees, minus sine of minus 66 degrees, the tan of 204 degrees. If sine 24 degrees equal to P, I'm reading the given statement. The sine of 24 degrees equal to P. Express the following in terms of P. It means that your final answers must contain P, and then you are not allowed to use a calculator. Hey, see what's happening here? Cos sine 24 degrees equal to P. Put P divided by 1. Joy, yes, that is correct. We put P divided by 1. That's correct. So in this case now, we can use a diagram. In this case now, we can use a diagram. Because in the diagram, the angle will be 24 degrees. Like Joy is suggesting, we need to put P divided by 1. Why do we necessarily need to put P over 1? Because sine is opposite divided by hypotenuse. So in the diagram, your opposite side will be P, and then your hypotenuse side will be 1. So that's why now we need to put P divided by 1. Okay, that is the diagram. And I already found the other sides. See, I started by saying we are given the sine of 24 degrees equal to P divided by 1. This is very important that you put P divided by 1 so that you can see, remember, this is opposite divided by hypotenuse. opposite divided by hypotenuse. Others say y divided by r, which is still okay. Whichever you remember, it's fine. It can be y divided by r or opposite divided by hypotenuse. We are doing this so that we can put the information in the diagram. And this is the diagram. And in the diagram, how did I arrive at the square root of 1 minus p squared? How did I arrive at the square root of 1 minus p squared? Tandega Tina is asking, say, I don't understand the p divided by 1 point. Can you please explain that once more? Okay, Tandega, what we are saying here is that, remember, of course, Tandega, any number is divided by 1. Any number is over 1. If I say A, so A is the same as A divided by 1. A divided by 1. So anything is over 1. Okay, Tandega? And then now I changed this P here, Tandega, I wrote it as P divided by 1 so that I can identify my opposite side and the hypotenuse side. Why? Because in the diagram, I will have the hypotenuse side, which is this side. This side here is the hypotenuse side. Remember, the hypotenuse side is the side that is opposite to 90 degrees. So this one will be your hypotenuse side. No, am I right? Yeah, hypotenuse side. And yeah, hypotenuse side. And this side here will be your opposite side. Or others say this is the side Y, and then this is the side X. So the main reason of changing P to P divided by 1 is that we need to have a ratio. We need to have something divided by something. That's why we had this. I think, Tandega, that answered your question. Okay, thank you, Tandega. I see Tandega has responded here. Yes, that answered your question. That's very good. Now I need something here. That's very good. So it is very important that William, yeah, you've got the answer. I see them. Most of you have got the final answers already. Yeah, the final answers is, yeah, everybody there. Frocius also got the answer correct. That's very good. No, Frocius, I think we missed something here. I think something is missing. Just check the calculations again. I think something is missing there. Just check the calculations again. I think something is missing in your answer. Just check your calculations again. Okay. Something that is not on here. Oh yeah, that is very good. William, you got the answer also. The answer is correct. That's very good. Who else got the answer? I did something. Miponi 1 minus, yeah, that's very good, Miponi. Your answer is correct there. That's very good, Miponi. Apiwe is also very good. You did very well. So I'm just gonna show you the answer now. I'm just gonna show you the answer now. Apiwe also, you got it very right. Okay. Okay, we used Pythagoras, remember? Remember we used Pythagoras to get the square root of 1 minus p squared. We used Pythagoras. That's very good. And then that will be, therefore, x is that. That's what we are getting there. And then cos square 24 as the answer. We all agree on the answers. 1 minus p squared will be the final answer, because what we did in this case is cos squared 24 degrees, which is cos squared 24 degrees equal to the cos of 24 all squared. Remember, we answered this question yesterday. What happens if you have got the square root, if your answer has got a squared? If your answer has got a squared. Okay, Aldesos, yeah, I wrote that. Say, yeah, that's very good. That's very good. That's very good. Yeah, I misread your answer, Aldesos. That's good. That's very good. Apologies. That's very good. I was thinking of something here. All right, that's very good. That's very good. You all gave the correct answer. I see William, he said, yeah, 1 minus p squared. 1 minus p squared. That's very good. Those are the answers to that question. And the challenge here can be to put this here. Cos squared 24 degrees. Remember, we said we put cos 24 in brackets and then you square everything. Cos 24 must be in brackets and then you square everything, so that you can go to the diagram and read what is the value of cos of 24 degrees. The cos of 24 degrees is read from the diagram. Remember the ratio for cosine. Cosine, remember, is adjacent divided by hypotenuse. It's adjacent over hypotenuse. So here I said adjacent divided by hypotenuse. Adjacent side over hypotenuse. Remember the ratio for cosine is adjacent side over hypotenuse. Or when others will just say x divided by r, which is very good. Whichever helps you to remember, please use that. X divided by r is also correct. So if you look at your x, that will be your x, or this will be your adjacent side, because that is 90 degrees. So this will be your adjacent side, the square root of 1 minus p squared. All right. And then your r will be 1. That will be 1 there. So that's why then I will then say the cos of 24 degrees will be the square root of 1 minus p squared divided by 1. But remember, it is all squared. You write that and then you put the all squared, because this can be a challenge to majority of us. What do you do with the squared? Remember, you square everything and the squared comes up alone. All right. And then remember, when we get here, square root of 1 minus p squared, the square root of 1 minus p squared, all squared will be 1 minus p squared. And then 1 squared, it will just be 1. And that will be the final answer. All right. Okay. So that is how you'll answer that one. Now let's move to question 2. Let's move to question 2. Question 2, what are we asked to do? They say we are still using the given statement. If sine 24 degrees equal to p, express the following in terms of p without the use of a calculator. Okay, number 1 is done. We did number 1. Number 1, we are done with it. The cos of 24 degrees is done. Remember, the answer that you got here, you might need it when you do question 2, so do not throw it away. Keep it here. Now we must find what? Sine 12 degrees, cos 12 degrees, minus the sine of negative 66 degrees, the tan of 204 degrees. Right. So how do we find that? Using the information that we have. Let's see, what are we gonna do here? Already you have got sine cos, 12 degrees, 12 degrees. You have got a negative angle here. You know very well how do we deal with the negative angle. You have got a tan of 204 degrees. Okay, see the answers are coming. Henry, sine 2a. What do you think sine 12 degrees cos 12 degrees equal to? Henry Moroka, I see you say sine 12 degrees cos 12 degrees equals sine 2a, Henry. What are others thinking? Half sine a. POS says is 2 sine a, 2 sine 6. POS said 2 sine 6. The sine of 12, the cos of 12. What are others thinking? What are others thinking? What are others saying? The sine of 12 degrees, the cos of 12 degrees, it will be equal to what? Okay, let's see what others are saying. 2 sine 12 degrees. Shamila says 2 sine, Yolanda sine 24 degrees, cos 24 degrees. Half of sine 2 multiplied by 12, Henry Moroka. Yolanda, 2 sine 12. Okay, so let's explain this. Let's explain that. Okay, I'm just gonna click here now. Let's explain that. We must find sine, given sine 24 degrees. We know that this one we know. We agree. So this is a double angle formula for sine. You see that, guys? Ne? I'm recalling this because this is the same as, it looks similar to that. That's why I'm recalling that formula. Okay? Because I've got sine 12, cos 12, sine theta, cos theta. So this given information here reminds me of this. That's why I'm recalling it. But now, how will I make it sine 12 cos 12? You see that I've got 2 sine theta cos theta. How will I make it sine 12 cos 12? Okay? Yeah. Divide by 2, Asane, that's very good. We need to divide by 2. Do you see that? We need to divide both sides by 2. So what do you notice now? If I divide both sides by 2, what do you notice? If I try to divide both sides by 2. So you get this now. You see that now, what is here, what is here is exactly the same as what is given here. So that means that where there is sine 12, cos 12, I will put half sine 2 times 12. Do you see? Because now in the given information, I see sine 12 cos 12. But now I know that the sine of 2 theta is 2 sine theta cos theta. So I can divide both sides by 2 so that that is similar to that. That's very good. See that some of you have noticed that, which is excellent. All right? Do you see now? You see what I wrote here? Let's go through these steps. Let's go through these steps. Let's start with that step there. Okay? So this is what is given. This one, sine 12 cos 12 degrees. It's from there. Then plus sine 66 degrees. Why now minus sine into minus 66 degrees? All of a sudden, it's changed to sine 66 degrees. Why? Remember, Remember what we have said yesterday and what we said in this lesson. We said all the negative angles are in which quadrant? All the negative angles. Say, for example, the sign of negative theta. The assumption is that they are lying in this quadrant. They are lying in which quadrant? The fourth quadrant, Mwiponi. Asane also says the fourth quadrant. That's very good. Remember, as long as you see sign of a negative angle, cos of a negative angle, etal minus times minus is a positive. That's very good now. Because what we will do here, we know very well that the sign of negative theta, sign negative theta is in the fourth quadrant because we say all the negative angles, the assumption is that they are in the fourth quadrant. So sign in the fourth quadrant is positive, it's negative, apologies, is negative the sign of what? Negative the sign of theta, negative the sign of theta, all right, negative the sign of theta. Similarly, the sign of what? The sign of minus 66 degrees, minus 66 degrees. The sign of minus 66 degrees will be equal to minus, because we say all the negative angles are in the fourth quadrant. So sign in the fourth quadrant is minus the sign of what? The sign of 66 degrees. So I put 66 degrees minus 66 degrees. So what we said, the sign of, we will say, or we have said, the sign of minus 66 degrees. Sign in the fourth quadrant is negative. Then negative times negative, it gives us positive. That's where this thing is coming from. Positive sine 66 degrees. Okay? So you will know that all the negative angles are in the fourth quadrant. And then sine in the fourth quadrant is negative. Negative times negative is positive. All right. Now, tangent, 204 degrees. 240 degrees is in quadrant number 3. What is the reduction formula in quadrant number 3? 180 degrees plus. Remember, we discussed that yesterday. 180 degrees plus. Plus what? To give you 204 plus 24 degrees. So how do you start your argument? You start your argument by saying 204 degrees is in which quadrant? In quadrant number 3. In quadrant number 3, what is the reduction formula? The reduction formula in quadrant number 3 is 180 degrees plus. But plus what? So that you get 204, you will say plus 24 degrees. Because say 180 degrees plus 24 degrees will give you 204 degrees. All right. Okay. So let's go on now. Go on. So this step, I assume that everybody understood that step. So it's sine 12 cos 12 as it was given here, and then plus sine 66. We discussed that, why this changed to plus 66. And then we also discussed why did we actually write 180 degrees plus 24 degrees. It's because 180 degrees plus 24 degrees gives you 204 degrees. Okay? Now let's move to the next step. Let's move to the next step now. Does the step make sense to you? Check. And remember, guys, here our key is 24. 24 is very important. 24 here is very important. And why 24 is very important? Because it's what is given. 24 is very important. We mustn't leave this golden number in this question, the 24. 24 is very important in this question. We must keep the 24. We must target the 24. As long as we are moving towards 24, then we are on the right track. So what happened here? This one, we discussed it entirely when we start with this question. Sine 12 cos 12 is similar to that. All right. From this, from cos of 2 theta, we said is that one. Right. Check there. This is correct. Check that one. Check that very well there. We said this, see, sine 12 cos 12 is the same as that. You see, and then on the left-hand side, we have got half the sine of 2 theta. See, I have the sine of 2 theta, but now in this, your theta is 12. Your theta is basically 12. Your theta here is 12. So where there is theta is 12. So where there is theta, I'll put 12. So it's half sine 2 theta, which means is half sine 2, 12. All right. And then 66 degrees, because I want 24. When will I get 24 here? I'll say 90 degrees minus 24. Good. 90 degrees minus 24. All right. And then that now, I'm interested in the 90, in the 24. That's why it's 90 degrees minus 24. Okay. And then now I move on. I think you know that sine in the tangent in the third quadrant. What is tangent in the third quadrant? It's positive. Oh, here I said negative. It must be positive then. Tangent in the third quadrant is positive and not negative there. Just correct that. Apologies for that. And then now if we move on with that positive, so the negative sign must change to the positive sign, because that thing there is tangent in the third quadrant is positive. And then we have got that. And then that is the final answer. That will be your final answer. Okay, I deleted it in the next step there. So the negative sign is not here. Remember that negative sign is not there because tangent in quadrant number 3 is positive tan 25. So that we keep it. And then remember, we just substituted using the diagram. The sine of 24 degrees, we already know it is half p plus the cos of 24 degrees will be the square root of 1 minus p times the tan of 24 degrees. It will be p divided by the adjacent side, because tangent is y divided by x. All right. So I see the time is not with us. Thank you so much. We will end the lesson here, and then tomorrow tomorrow we will look at the probabilities. I do believe that you did learn something from this lesson, and then tomorrow at 3 o'clock we will continue with our next lesson, and our next lesson tomorrow will be based on probabilities. Please join us tomorrow at 3 o'clock to go through the lesson on probabilities. So I'd like to thank everybody for being part of this lesson.